There are many different experiments that prove that dark matter actually exists because of gravitational interactions. But nobody can tell you what it really is. So the nature of it, what is it? Is it a particle? Is it many particles? What is it? So this is one of the sticking points in the Standard Model. The Standard Model is clearly something that is incomplete. It is great to have it and to have the Higgs boson that is making now the Standard Model actually work in the area where we are looking. But there is this effect that there's so many things that the Standard Model doesn't explain. Probably one of the most prominent ones that everybody immediately thinks about in our community, probably also in other communities, is, well, what is actually dark matter? Dark matter is something that we all know exists. There are many different experiments that prove that dark matter actually exists because of gravitational interactions. But nobody can tell you what it really is. So the nature of it, what is it? Is it a particle? Is it many particles? What is it? So this is like one of the sticking points in the Standard Model. The Standard Model doesn't tell you anything about that. Other things like, well, gravity. Gravity is not part of the Standard Model. It's actually a massive problem. How can we actually not understand how gravity works? Gravity is, of course, as compared to all of the other forces that we have, it's so different. It's so weak. It's insanely weak, right? So it's something that they're almost like separate because they're so different in terms of their strengths. That, for example, when we accelerate electrons or protons and we make them go around and collide, we never have to worry about gravity because the force is just so insanely weak that, I mean, it's 30 orders of magnitude weaker than the other forces. So this is completely irrelevant. I mean, yeah. So there is all of these things that the Standard Model doesn't explain. Well, why is there so much matter and almost no antimatter, right? In the process of the creation of the universe, you would imagine that matter and antimatter to a large extent should be created in equal parts. Sakharov conditions tell you that you can actually create a symmetry, but this asymmetry that basically is formed on these assumptions is so small that it would never allow the universe to exist. So that is, again, an indication that there's something in the world that the Standard Model does not capture. So there's a big problem with the Standard Model, but of course, as somebody who just found the Higgs boson, I'm really happy that the Standard Model for now works very well, and the Higgs was actually this missing piece that we found after 48 years.
It sounds like more updates are coming from the Standard Model.
Oh yeah, well, I mean, like, clearly that's the future. We're working on that. Absolutely, yes.
It's very interesting. I'm a chemist, so a little bit more of like a layperson when it comes to these topics. And when I was preparing for this event, I was struck by this similarity. Like the Higgs field sounds a little bit, to me, coming from outside the space, it sounds a little bit like the ether. Doesn't it have like a similar, it's like everywhere all at once, and there's this, perturbation in it, the Higgs boson. It sounds a little bit like the ether to me. Is that like a really poor analogy? But it has that feel, at least just, from a couple hours of reading about it.
So the comparison between the Higgs field and the ether, that's an interesting question. It fills the space everywhere, right? That's, of course, what the ether does. I think the ether concept was something which was about trying to understand how light is actually propagating, so it was transporting light. The analogy of that I can see with the Higgs field goes as far as saying, well, it is everywhere in space and it fills it, and we just can't feel it to some extent, right? I mean, the ether was something that also was not noticeable at the level of, well, you and me here sitting in the room. The ether is there, but we don't have no way to interact with it. The same way as we don't have a way to interact with it here with the Higgs field. But then the reason for its creation was quite different, of course. So the reason for the creation of the ether at the time, as far as I understand, is basically, well, the speed of light, how is actually an electromagnetic wave propagating through space? Is there something? And I think that's not what the Higgs field is. The Higgs field is like this presence which every particle moves through it and it interacts with it. if it's not a photon. The photon has no mass, so it does not actually interact with the ether in a sense, because it doesn't have a mass. It doesn't couple to the Higgs at all.